All right, so just to set the stage, I will be talking about the Hedvig being used as backup target, and Lucy will be talking about just completing the whole picture of protocol consolidation, so how we work as object storage. So these are the two things we'll quickly cover in this small session. And in terms of Hedvig as backup target, why do we need another backup target process? So you have things like data domains or hexagrids or quantum that already exist. What was missing? That's what we found out in last 1 year or so from hearing, of course, from our customers, what are the things that they needed. They, of course, needed your backup targets to be very simple to consume. They needed to be ridiculously cheap. They needed, one thing all of them asked for, if not now, in future, they will move some of their data to cloud. They wanted that capability to be your platform, your storage as a backup target should give you that option, that if I want to move to cloud, I should be able to do it, which you guys might have already seen. Of course, you have already seen this hybrid cloud and multi-cloud capability that we have. So it's already built into the system. The only thing that was remaining is performance point of view. And there are a lot of characteristics of backup applications that you can take care of from a storage point of view and make your storage a lot more performant. And that was a missing piece that we wanted to take care of in treating Hedvig as a backup target. And that's what we did. So let me quickly show you the option that you already might have noticed in the demos. When you do this, add this, you will see this backup grayed out option. And that's what I'm talking about. And this is only becomes available when you select this type as NFS. And so the whole point of selecting this backup option is our NFS disk to become a lot more optimized for these backup workloads. And when I say optimized, what I'm really talking about is there are two things, of course. It's the ingest and then the restore itself. So the backups and restore in that sense. So what have we done? So in case of backup, the characteristic that you use for backup workloads, it's all single writer scenario. And we don't have to worry about global lockings in those use cases. You're right, a backup application is writing to one backup image. Concurrently, it's sure, but as in a single client scenario, not in a concurrent client or multi-client scenario. So that's the characteristic that we use to optimize our ingest in case of backup. In case of restore, we do massively parallel, or let's say a lot more parallel read aheads and much more distributed parallel reads when the restore happens in this NFS disk. So that's another characteristic that we can leverage. And the third one is the deduplication itself. So this retention policy that shows up here when you select deduplication, of course, won't show up if you don't select backup. It's very backup specific. So when you have backup option selected in Hedvig, and then you select deduplication, another dropdown comes in which this retention policy, everyone knows what retention policy is. What we as Hedvig want to do is tie up end-to-end solution from your front-end backup application to a back-end storage, a back-end backup target by using this hint. So it's more of a hint from your backup application saying that I'm going to store my 2 weeks worth of data in this virtual disk. You might select another NFS virtual disk in Hedvig and select 1 month. I'm going to store 1 month worth of data in this disk. And again, I want to stress on the fact that it's hint. It doesn't mean that we are going to start deleting stuff after 2 weeks. All it means is we can perform our, let's say, garbage collection process in the backend for dedupe and other metadata purposes a lot more optimized way. So that becomes very backup specific, and that's the optimization that we have put in. And in case of backup type, you would see two different options. So for example, OST and Hedvig. Some of you might already know OST is nothing but NetBackup's way of providing third-party storage vendors to more natively integrate with their systems. So you can do a lot more performant operations. And Hedvig type, backup type is Hedvig, is for everything else. So you can create NFS disk, select the backup as Hedvig as the backup type, and export it to your media server, media agents, backup proxy. These are all the same terminologies in different backup applications. And then you can have all those inline deduplication, compression, all built in the system. So that's how we solve this backup target problem in Hedvig. So I'll put it to object storage. for Lucy.
Hi, everyone. My name is Lucy. I'm also an engineer here. I'm one of the early engineer to fulfill the completeness of the protocols provide the platform that offered by Hedvig a storage service. So object store, like compared to as we are gaining more customer attention on this piece. So compared to like a traditional file storage, block storage. So object storage is maintaining your data in objects and while offering a lot of benefit on managing those objects. So one of can I show the slide? So usually there's use cases, a lot of use cases we see in customers that consuming our object storage like in archiving. So you will feed time series logs, and for those or metrics, for those use cases, you will be expecting an expiration rule and like to very customize the rules to manage your objects. Say, for example, I have a 2018 year of log, and I just wanted to stay for 1 year and then just to clean up by some housekeeping background service. So, and another use case is people are going to host website on top of, say, for Amazon S3, they will just build up their website around it and then store like image, for example, a Hedvig logo, such static image content, and to build up their website. So this will be, this is meaning that we'll be seeing small object storage, and then as long as with the intensive metadata operations to put attached with each object. And third one is, of course, media image storage. You will store your photos and videos on top of it, which means could be multiple gigabytes, and which means it's a large object consumption. And you will definitely see some user needing for data protection. What if you accidentally overwriting it or deleting it? So. As my fellow colleague introduced the Hedvig storage platform, so as object storage, we're going to enjoy all the benefits that are provided by this platform: deduplication, encryption, and also very flexible replication policy. It's also able to use that in object storage. So in object storage, that if you are familiar with the S3, and you will see the bucket, we maintain those objects in the bucket. You maintain those objects inside of bucket as a file, and you can also create inside of the bucket a kind of file system like hierarchical to maintain those files and objects within. And so in our a little bit into implementation, so object storage, Hedvig object storage does not layer on top of the traditional file system. So we don't layer on top of a file system to build our object storage solutions. Instead, we're using metadata process and data process we introduced before in Hedvig storage platform, and to store the object metadata into the metadata process and the actual data inside of data process, which will be seeing all those benefits offered by the platform. And so as you can see inside of this node cluster, so I'm having these three. You can see on this column, which indicates their protocols. So you can see object store, VDIs are created alongside with other protocols. And so this is a bucket, S3 bucket. I created bucket 1, bucket 2, and test files. And in our implementation, each object is also a virtual disk. So which means you can switch on and off, like deduplication, encryption on an object level. So this is... For now, you're not going to see here because it's going to be a lot of objects. So I'm going to show you some very commonly used on-market GUI to give you a...
So the replication, encryption, deduplication aspects are not at the bucket level, they're at the object level?
Bucket level, you can select it, and object level, you can also, like, for example, encryption, some objects you want to turn it on, some object you want to turn it off. So.